Hello to everyone in the audience. I'm Sagita Mirjam Sunara. I'm an assistant professor at the Conservation Restoration Department of the Arts Academy, University of Split. I will talk about a problem-based learning assignment that I designed for one of the courses I teach at the Integrated Undergraduate and Graduate Program of Study in Conservation Restoration. This was a preventive conservation course that students took in the second year. The assignment was intended to familiarize them with the concept of risk assessment. On this slide, you can see the students who participated in the assignment. There were 10 of them. That's how many students we accept in our program each year. The students had already completed a course on the basics of preventive conservation, which I teach in the first year of the program. As a part of that introductory preventive conservation course, this group of students attended a lecture by a visiting expert, José Luis Pedersoli Jr. of Vikrom, co-author of the ABC method, a risk management approach to the preservation of cultural heritage. So the students had already heard about risk management. The assignment that I devised for them focused on real heritage objects. I used 3 sculptures from the Sisak Steelworks Sculpture Park as case studies. Sisak Steelworks Sculpture Park is a collection of 38 outdoor metal sculptures that were made by renowned artists from the former Yugoslavia during the 1970s and 1980s. And I have been involved in the study and preservation of this collection since 2012, when it was inscribed in the Register of Cultural Property of the Republic of Croatia. The first sculpture I selected was The Work Process by Saša Stevović. The sculpture is made of steel. It rests on a low cement plinth and is sited near a road that connects the former Sisak Steelworks and the nearby housing estate. The second sculpture was Dark Visions 1 by Josip Zeman. This sculpture is made of galvanized steel and is installed in the middle of the park that separates the factory from the housing estate. It lies directly on the ground. The third object was a painted steel sculpture, Wall by Dora Kovachovic. This sculpture is located in the Steelworks housing estate. It's not properly installed, rather leant against a wall of a residential building. As you can see, the 3 sculptures differ in material, size, form, and location. The students had not seen the sculptures in person. I provided them with some photographs and pointed them to Google Map on which the sculptures' locations are marked. They had little information about the artwork state of preservation apart from what they could discern from the photographs. And for this reason, they were not required to consider the physical condition of the object when working on the assignment. Let's now see what they had to do. I initially asked students to produce an essay in which they were to explain what threats is each sculpture exposed to, how can damage occur, what measures can be taken to prevent damage, which people and/or services can help implement the proposed measures. I also asked them to explain who should respond when a sculpture gets damaged and what the chain of responsibility should be. The essays that students submitted varied in quality. As you can see here, some of them produced an extensive text with illustrations, while others kept it very short. Of course, length of the text is not that important. The content and its organization are key for judging written assignments. Now, going through their texts, I could see most students did not approach the problem systematically. They did not take into account all the threats that the sculptures are exposed to and all possible incident scenarios related to those threats. And when considering individuals and services that could be involved in the implementation of mitigation actions and measures, most students mentioned only conservative restorers. I was of the opinion that a better result could be achieved if we tackle the issue gradually and if I provide more guidance to the students. So, I asked them to read each other's essays and to critically evaluate their own performance. Then I asked them to write incident scenarios for 10 agents of deterioration for just one sculpture. So I assigned each student one of the 3 sculptures and they had to write incident scenarios for all 10 agents of deterioration. They had to extract the scenarios from the essays. Now, this was not so easy as the scenario descriptions in the essays were mostly incoherent. So the text had to be amended so that it provided a thorough explanation of the sequence of events and how the resulting damage is manifested. And in the bottom left corner of this slide, you can see a correction example. And to make sure students did this in a systematic way, I provided them with a form in which they had to enter this information, and I also gave them some examples. I collected and reviewed all forms in the end, and from this material I extracted 78 different incident scenarios. And here you can see how they were distributed across the 10 agents of deterioration. So there were 16 different incident scenarios related to physical forces, 6 related to fire, 16 related to water, and so on. We then moved on to the final step of the assignment. I asked the students to A. propose mitigation measures for each of the 78 risk scenarios, and B. to consider which individuals or institutions can help implement the measures they are proposing. Now, I want to give you a glimpse of the results of this enormous work, so I will now focus on the second and the third step of the assignment. I will use this sculpture, the one installed near a road, and physical forces as an example. So let's see how this particular artwork can suffer damage from physical forces. Students managed to identify 7 incident scenarios. If someone is driving too fast or under the influence, a car can fly off the road, hit the sculpture, and physically damage it. The force of the impact can cause the sculpture to fall off the concrete plinth. Gravel or other rock material can fall off passing trucks, and the cars can propel the gravel or rocks toward the sculpture. This can lead to surface damage, chipping off the metal, for example. During grass cutting, a mower or a trimmer can propel gravel or small rocks toward the sculpture. Again, this can lead to surface damage. Due to road traffic, the sculpture is subject to vibration, noted the students. This can expose the material to strain and lead to microcracking. Solid particles carried by the wind can abrade the surface of the sculpture. A strong wind or a storm can break off a branch from a nearby tree, which can land on the sculpture and cause scratches on its surface. And finally, a lightning strike can locally melt the surface, deform the sculpture, or even completely destroy it. Now, obviously, some of these incident scenarios can be applied to the other 2 sculptures, the one installed in the park and the one located in the housing estate. These sculptures might exhibit different types of damage because they are made of different materials and are different in size and form. It is important to keep in mind that the other 2 sculptures have incident scenarios that are specific to them, and that is why I said that students came up with a total of 16 different scenarios related to physical forces, and I have only shown you 7 in the previous slides. After all the different incident scenarios were identified, the next step was to propose mitigation measures and to determine who could implement them. And let's take this incident scenario as an example. If someone is driving too fast or under the influence, a car can fly off the road, hit the sculpture, and physically damage it. And then the force of the impact can cause the sculpture to fall off the concrete plinth. The first question is, what actions or measures can be undertaken to mitigate this damage? Well, as far as I can tell, there are 2 lines of actions. We can, 1, slow down motor vehicle speeds, or 2, we can minimize impact damage, or impact force to be more precise. How can vehicle speeds be reduced? Well, here are some options. We can install speed limit signs, speed humps, speed cameras, or periodically conduct speed controls. What about impact damage? How can that be minimized? Again, there are several options. Move the sculpture away farther from the road. One way of doing this is by switching the position of the footway and of the green surface on which the sculpture is installed, but there is a limiting factor. This intervention would impact pedestrian safety. Another option would be to install a fence along the road, or yet another option to install the sculpture on a high or a higher cement plinth. But these 2 interventions again have some limitations to them because they could have a negative effect on the visual experience of the artwork. The second question is, or was, who do we need to collaborate with in order to implement these measures and actions? Just to remind you, here is the list of the proposed mitigation measures. So, who is in charge of motor vehicle traffic? Well, road authorities and the police force. And who could be involved in impact damage mitigation? Again, road authorities, but also municipal planning service. And we should seek the artist's approval for the proposed reinstallation of the sculpture. I will not go further into this. I will just say that each of the 78 scenarios were elaborated in the same manner. I covered 3 scenarios to provide students with an example of how this should be done, and they, working individually, covered 75 scenarios. So each student covered 75 scenarios. Now, in this assignment, students were not asked to determine if the sculpture installed near a road has a bigger chance of being hit by a car or being damaged by a fallen tree, and which of the 2 events would result in greater damage or greater loss of value. Those kinds of estimates would require far more data and much more time. So what students did through this assignment was not risk assessment. they did not evaluate the probability of incident occurrence, nor did they quantify the resulting loss of value. If they had done that, they would have been able to prioritize mitigation measures. Still, this exercise managed to familiarize students with the concept of risk assessment. The assignment as a whole made the students rethink and expand their perception of preventive conservation. And I'm sharing here with you an excerpt from the 2016 interview with Stefan Mikalski of the Canadian Conservation Institute, in which the interviewer states, traditionally, preventive conservation has been based on recommendations and standards for relative humidity, temperature, lighting. The first steps towards risk assessment happened in the late 80s and early 90s, and Stefan Mikalski confirms, yes, preventive conservation began with the focus, almost an obsession on climate and light, and many are still stuck there. Maybe this was also the perception that my students had of preventive conservation before we embarked on this assignment, but the assignment, I'm sure, drastically changed their views. I think that the most important lesson the students learned was that heritage objects are exposed to an extremely wide range of threats. And when we design a preventive conservation plan, we need to take this into consideration and we need to approach the task systematically. Another takeaway point was that when it comes to the implementation of risk mitigation measures, conservative restorers don't have to be like a Swiss knife. We cannot do all the work on our own. We need to identify potential partners and establish collaboration with them. Preventive conservation requires a collective effort. Did the CSAC sculptures benefit from this assignment? Of course they did. The threats to the 3 sculptures were recognized, mitigation measures recommendations developed, and key actors identified. And these data can be used to create a preventive conservation plan not just for those 3 sculptures, but for other similar works in the collection and elsewhere. If more sculptures from this collection are analyzed in this way, a catalog of different incident scenarios and mitigation recommendations can be produced. And in future, more factors that determine an object's vulnerability to damage could be included. As a final result, I imagine a database in which one could enter sculpture attributes, for example, painted steel, urban area, under a tree, and a list of all incident scenarios would be shown along with possible mitigation measures. It would be, I'm sure, an extremely helpful tool in preventive conservation planning. Thank you for your attention.